Remind you that our investigation, you will get your drafts back when we've finished our test. And our test is going to be next week in our double lesson. So we should be pretty good. I'm aiming to try and finish everything by our double lesson tomorrow. But just had a chat. Some people didn't, finish up and look at their homework. So you've got to make sure that you're doing that. But what you will find is things are now repeating. So hopefully it will be nice. Make sure that you've got a graphics calculator in front of you, please. Remind me about our discriminant. How useful is it? What does it tell us? Dimsy's retrieving himself.
The function is going to be crossing x-intercept.
So, how many times, excellent, how many times are we talking about x-intercepts? How many times is going to cut the x-axis? So when the discriminant is?
When discriminant is greater than 0, then it's going to be 2.
Cuts twice, yep.
And if it's 0, it's going to be once.
Touches.
And if it's not less than 0, then it's no real.
Love it. No real solutions, and that means it doesn't cut at all. We can extend that to when we have two functions here. We've got a quadratic function and a straight line. We want to find out if they actually meet. So if they're going to meet, twice, that's, again, we make them equal each other. We get everything on one side, and lo and behold, we get a quadratic equation. So when they equal each other, and we get that quad equation, if the discriminant is greater than 0, then that means they meet twice. And I think you get the gist. If they don't meet, that means the discriminant will be less than 0. So we take it up to this situation. Now, I had someone asking for question 7. Did we have success with 6? So if you didn't, and you're too shy to say, we'll do 7, and then we can come back and address any concerns with 7. So if you haven't done it, make sure you've got it down. If you did do it, you're helping us out because we're going to move along pretty quick. So we've got two functions. Find the value of m for which the line cuts twice. As soon as we're saying, so cuts twice, intersects, what does that mean? First thing we do is we will saying discriminant greater than 0. I like that. But I guess the first thing we need to do is actually work out our quadratic sort of situation. So we have to make these little guys equal each other. But I love how you're going. If it's tangent, what does that mean?
That the discriminant equals 0.
Yes, because a tangent means it's just touching. So again, touching once, touching, we go, and we know the rest. So the first step that we should do is actually just make them equal each other. So we've got minus x squared plus 3x, take 6, bless you, equals mx, take 2. Yeah? And it's all about just do something. So now what are you going to do? Yes?
Put all the...
Yeah, it's a quad, so we want to make sure everything is on one side. This is stuff we already know. What side do you want to pop it on? Does it matter? It doesn't matter. What side would you choose? I know which one I'd choose. Would you? You said left. I would actually go right. Do you know why?
To make that x squared positive.
Yeah, I just make my x squared positive. Now, it wouldn't matter. It's just, I don't know. I just like to do that. So it becomes x squared. And then I've got mx, take 3x, and get rid of the minus 6 by plussing 6, so I get plus 4. We? Who did this nicely? 1, 2, 3. Okay, so we've got that. I can fiddle if you want to, because to get my b value, it's the coefficient of x, so I'm pulling out x as a common factor. Now, would you agree every single one of you should be able to get to that point? You're just getting your quad. And we know this is all, as soon as we see a question where it's cutting twice, touching, or not, doesn't meet at all, or it could be 2 solutions, 1 solution, no solution. Straight away, we're going to go, discriminant. Okay, so let us find our discriminant. So if you haven't done it, I'll give you 5 seconds to be ahead of me. Go, find the discriminant. B value is m minus 3. We're squaring that. Take 4 times your a value, which is 1, times your c value, which is 4. And we're solving for that to be greater than or equal greater than 0. Simples? It's reminding you how to expand properly. So when we've got a perfect square here, ooh, I could expand. Oui. Everyone's nodding. So if I was to expand that, what would you get? You should better tell me in your head. M squared, take 6m plus 9. Yep. I'm going to be a bit sneaky here, and I'm not actually going to expand, because I get take 16 is greater than 0. What I can now do is whack that 16 on the other side. Yeah? And how do I now get rid of the squared? Square root. And when I get rid of when I square root the 16, just remember, it can be plus or minus 4. And for those of you who didn't do it that way, if you expanded, you would have got m squared take 6m plus 9 take 16 is greater than 0. So you ended up with m squared take 6m minus 9 take 16 is thank you 7, and then you have to factorize that. So what are the factors of 7? 1 and 7, so it's minus plus, and you're going to get exactly the same answers here, because how do we now get rid of the take 3? Plus 3. Okay, so we've got, I'm just going to replace that with an equals for now, because you'll see what happens. We've got that plus 3, or we've got m is minus 4 plus 3, so we've got minus 1, we've got 7. So the same answers that we get here. Okay? You need to be able to do both. But Houston, we have a problem, because I cannot say that m is just greater than 7 and greater than minus 1. Why? We've got minus 1, we've got 7. If I've said greater than 7 and then greater than minus 1, I'm also including all of this stuff, and that's not actually going to be the case. So quick little sign diagram. We haven't had to think at all. We just put our values on. We pick a number beyond 7. 10. I love 10. It's just easy, right? And we pop it in. You can put it anywhere you want. You can put it here. You can put it here. I'm going to pop it here. What's 10 take 3? We happy? 7 squared is 49. Is that greater than 16? Winner, winner, chicken dinner. What's the number in between minus 1 and 7? 1 minus 5. Could use all of those. Guess what I'm going to use? 0. What's 0 take 3? Minus 3. What's minus 3 squared? Is 9 greater than 0? No, doesn't work. Pick a number beyond minus 1. I mean, can you predict what it's going to be? Minus 10. Minus 10 take 3 is minus 13. What's minus 13 squared? Greater than 16, right? Works. So therefore, how do we write this? We write this that m can be less than minus 1. M could be greater than 7. Agreed? Do I have to do any more calculations to work out this one? When is it equal to 0? Well, it'll be equal to 0 when m is minus 1 and when m is 7. Agreed? And how will I know when it is not touching? So when is the discriminant less than 0? That's going to be in this zone here. How do I write that? Do we know how to write that or not? I've got one person nodding. What's the rest of us? So some shake of the heads, that's great. Otherwise, I'll just move on. So in English, we would say m is in between minus 1 and 7. And if you write that, I will mock you, right? Mathematically, we will write in between minus 1 and 7. So it's less than 7, but greater than minus 1. And that's what you would write. Show that any linear function passes through P0, 3. It's just like question 6 and 7. You just have to add one little bit to it. Okay? So, do you agree all linear functions are of the form y equals mx plus c? What does the m stand for? The gradient / slope, yep. And what does the c stand for or represent? The y-intercept. Now, do we have the y-intercept? So according to this, we've got a function now. It could be going through like that. It could be going through like that. It could be going through like that. There's infinitely many straight lines that will pass through that point. Okay? So we're just going to call it y equals mx plus 3. So here's this function, here's this one, and we're going to do the same thing. We're going to say, right, that's not very nice. We're going to say 2x squared take x take 2 equals mx plus 3. What would be your next step? Not common factor, my friend, not yet. Yep.
Bring everything.
Yeah, get everything on one side. As soon as you ever see a quadratic, straight away, all on one side. You want to make it equal to 0 because that's how we solve it. Yeah? Whoosh. So 2x squared, take x, take mx, take 5 equals 0. All right? When it's saying it will meet twice, what does that mean? Discriminant will be greater than 0. If this is a test question, assignment question, even in your books question, you should still write that down. It helps you do the next step. It helps the marker go, oh yeah, at least they know this much. All right? And we're going to go forth. I think it's pretty clear that my A is 2. What are you going to do for your B value? What's your B? Pardon? Is it just negative m? Because this is where you've got to be pretty careful. Can you see that you've got actually 2 x's there? So if that was like minus 3x take 4x, you would then say that's minus 7x. So that is your value. So with this, you're going to make sure that you have, if you want to, once again, I like to pull out my negative, or let's go positive. So would you agree it's minus m, minus 1 take m is your B value, right? Or it could be minus x 1 plus m. I don't mind either of these. In fact, I prefer that because your B value would then be minus 1 plus m. And when you're squaring it, b squared minus 4ac, what happens when you square a negative? Becomes a positive. So you don't have to worry about all that paraphernalia. Up to you. Okay? And we know our C. So isn't that just like the questions that we did before? So finish that if you so desire. And then have a look. You're scrolling down your textbook and we're going to do some of these. And we're going to use our calculator to help us so we can move it along pretty quickly. All right? So give you 5 minutes. Finish off. Have a read of the next example if you want to, and then we'll get cracking. They start off very nice. I could pull these questions from your Year 10 book as well. So let's change up the colour. Green. 2 integers differ by 12 and the sum of their squares is 74. Find the integers. You just have to write that in mathematical terms. So 2 integers, and they differ by 12. So do we know what the 2 integers are? What shall we call them? Let's call one x for variety. We're going to call one x. What's the other one? You could call it p or y, whatever, except they differ by 12. So if one's x, what's the other one? So it could be x plus 12 or it could be x take 12. Doesn't matter. Yeah? So what would you like to call it? Thank you for participating. Well done. X take 12. Now, the sum of their squares. What does sum mean? We know this. Add the sum of their squares. So would you agree it's going to be x squared plus what? Yes, x take 12 squared, right? And what do we then say? Equals 74. Yes? If it said solve this algebraically, what are you now going to do? Expand. Get all things together on one side. You'll look at it, you'll either factorize or quad formula. If it did not say do this algebraically, what could you do at this point? There's silence from the crowd. Calculator! Absolutely calculator. Who knows how they could do this on their calculator? So some people are reaching for their calculator, but no one's actually put their hand up. One person's put their hand up. Yep. How would you do it?
Using solve.
Solve n. Absolutely. Okay. So just remember, in your calculator part, you are expected to be able to use technology. So let's just remind you. We go into, how do I get to solve n, peeps? Option. Okay. We're going to go to option. And we want to calculate something. So we're going to go to calc. And there's solve n. And then you can just type in what you see. So what was it? It was x squared plus x take 12 squared. All right? Your equals is above your decimal point. Close your bracket. Enter. Yeah. This now makes sense when they say there could be more than one solution. Because obviously we could have up to 2. 5 and 7. Bang, done. So one of the issues in your test, if it does not say do it algebraically, but you choose to do every question algebraically, you will run out of time. That doesn't sound good. Is that the elevator? Not another evac, please. Okay. Number 2, it's all about writing the equation. And remember, if you don't know, you just try and put something down. The sum of a number and its reciprocal. Has anyone heard of what reciprocal means? Go ads, yep. Flip it, it's 1 over, okay? So when we had perpendicular slope back in year 10, the negative reciprocal, you flip it. So if I've got x, that's the number, what do you think, how do we write its reciprocal? 1 over x. So those are our 2 values there. So we've got x plus 1 on x equals 26 over 5. Now again, you could go straight to your calculator. Bless you. But if I said express this as a quadratic, I don't see an x squared. All I see is this over x, and I don't like it. So how do I get rid of it? How do I get rid of a divide by x? Times. Shh. And Gracie, I don't know if you remember, but we had questions like this when we were trying to solve quadratic equations. We might have had blah, blah, blah equals something. How do I get rid of the divide by? You times every term through by x. So, hallelujah. There's our quadratic. Get everything on one side. There's no way that I'm going to waste my time trying to factorize this. It's got a fraction in it. Okay, if it was saying do it algebraically, then I'd times through by the 5 to get rid of that fraction. But at this point, I'm just going to go, stuff it. Let's go calculator. And let's mix it up. Where can I go? Somewhere different on my calculator to solve this. Equation, that's the way. So do you see how we're sort of revising, we're revising some of our calc things. So we're going to go down to equation. And then poly, degree 2, and we're just going to pop in our value. So 1, and then it was negative 26 over 5, and then it was, I can't remember, 1. I shouldn't play the memory game. And there we go, our values. Okay. Once again, we shouldn't be waiting 5 minutes to try and find out, oh, how do I use my calculator? Where do I go? It's bing, bang, bob. Go quick. So we're just saying here, what happens if this was worded as algebraically solve this and you don't want to use 3? Hello, boys, can you please listen? If I asked you, I want to factorize this, or does it factorize, you can still go to your calculator and you can use it to work backwards. Okay, so you can go into your poly. It was 1, positive 1 or minus 1? Positive 1. 1, negative 360. Oh, well, we can't factorize. But let's imagine, instead of these massive answers like so, what happens if you got something like x equals 18 and x equals minus 19? Remember from the work we did with the graphing? If those were my solutions, doesn't that mean I've got a factor and another factor? So just because it says factorize, if you can't factorize something, you can use your calculator to work backwards. Don't forget that. In this case, no. Did I do that right? How embarrassment. Did it wrong. Because I did not read the question well enough. Because the product of 2 consecutive even numbers. So how do I then change that? How do you know that a number's even? It's divisible by 2. So if I take a value and say, let's call that 2x, wouldn't that have to be even? What would be my next even number? So let's, plus 2. So 2x plus 2. So you do the same thing, but now it's just 2x plus 2 equals, I threw 6 there. Go solve it in your calculator and it's better. Make sense? We've got a D here, we've got an N. What does N represent? The N is the number of sides. That's what you're trying to find. What does the capital D represent? The number of diagonals. So isn't this saying D actually equals 90? So all you have to do is slap 90 in here and you're solving. Instead of N, instead of X, it's N. Ooh. Okay? You can mix it up. You can try and solve algebraically, or you could use your calculator. Your call. Mix and match. Try the next one. I'd like to think you're a step ahead of me. So if this again, question that you might not have done before. What's the first thing you should do? Go do something. I'll pay you $50. Do something. Monopoly money. Or Jaden, 50 Bitcoin.
Awesome. I'll ace this class for 50 Bitcoin.
Is it? Oh, it's 50 Bitcoin a lot?
Quite a lot.
I take it back. Right, anyway, what is the first thing that we should actually do? Pardon? Okay, you've read the question. Girls, do you mind? We've read the question. What's next? Come on, do something. I know you know. Come on, Kai, you got to do something. What will you do? So people struggle with this, like draw a diagram, put your information on, right? Length of a rectangle was 4 centimeters longer than its width. Didn't know the width, we called it X. That was from the class. I would have called it W. And then X plus 4, W plus 4. Area is length times width. All right? And sub it in. Now solve it. If it was algebra, then you'd have to expand, get everything on one side, and probably quad form. If it didn't say solve algebraically, go your calculator into the solve n or into polynomial, up to you. Hello, the 3 people on aquatics at the moment. It's sun shining over here, so we hope it's sunny where you are and not freezing, and you haven't fallen in to the river, sea, ocean, wherever you may be. Here's some mystery students. See if you can pick who they are. Oh, they've gone very shy now.
Element, what are you talking about?
Oh, no names, no names.
I want to give it away that it's me. LMA, guess who?
Don't say her name.
David's.
Anyway, there you go. So this one is all you. All I'm going to ask is that you remind each other, how do we find the surface area of a box? I'm coming to you. How do we find the surface area of a box? No one knows you're here. Pardon? You just find the area of every face. What shape is each face here? Rectangle or square? So I think I'm going to leave that to you. You should be able to. Now wait. If you couldn't find it, they've actually given you, they've given you the answer here. So you have to try and work. It's giving you a clue, so you can work towards it. Again, if this was a test question, don't think if I can't do A, then all hope is lost. You can still carry on and solve that equation. Oui? Are there any limitations on the value of X? Ladies, asking you a question. Are there any limitations on the value of X here? Why can't it be negative? It's a length, that's right. So whatever you're doing, you have to make sure that it's going to be greater than or equal to 0. If it's 0, the box doesn't exist. So if you were to solve some of these questions and you get a negative answer, right? If it's talking about volume and dimensions, whatever, don't give me a negative length, right? Suss the question. Capiche? Carry on. So some people were just saying, not quite sure how we actually get this. So let's have a look. You've got a box. First thing that you should say, and girls, you need to now not talk. The first thing that you should be saying is, once you've read the question, its height is 1 centimetre longer than the base. So I'd like everyone, if they've got their diagram, which you should have had by now, you should have put there that that height is x plus 1. And now that's probably, you can't see that very well in case it's, so we'll go here. X plus 1. Agreed? Now, that means the faces of the sides are x plus 1 times x. So what's the area of a face? A side face. Isn't that going to be x times x plus 1? Agreed? So that's the sides. And then what about the base and the top? What's that? Oh, year 11s, come on. X times x, thank you. It's a square, so plus the top and the bottom. You're going to add on 2 lots of x squared, because you've got x times x is xy plus another. So when we add all of these together, what are we going to get? Oh, and so, by the way, how many sides did we have? No, sorry. How many of these sides did we have? 4. So you're going to have to times that by 4. So your total area is going to be 4 lots of x times x plus 1 plus 2x squared. Because I was just chatting to you as we were doing this, my setting out is probably a bit poor. If that was an assignment or a test question, right, I would be writing I would be writing 4 sides plus 2 bottoms, and then put my answer underneath that. Okay? You're going to expand this, and that will give you what we have. But we're talking about working out the area of several rectangles, peeps. Let's put our thinking hats on. I know it's early in the morning. Okay, for number 11, as we said, when in doubt, draw a diagram. A stone is thrown into the air from the top of a cliff 60 metres above sea level. So let's say the cliff is here. That means we're at 60 metres, correct? And then it goes up, and then it comes down. The stone reaches a maximum height of 80 metres after 2 seconds. So what is this point here? Pardon? What would that coordinate be? It is a maximum. Would it be 80 and 2? 82 would be out here. Okay? 280. And you need to find the quadratic function. Now, if you go back a couple of lessons ago, we gave you all these diagrams and you had to find, probably gone too far, oh, I went too far. Right? Find the equation of these functions. Pretty much the same thing. You hit the nail on the head when you said maximum. What's another word for maximum? Vertex. We see vertex. What should we be thinking? The XH thing. Absolutely. Okay? So that should be y equals a x minus h squared plus k. Oui? I've still got time. So what am I going to write now? You've played a lot. No, you go. Keep going. Yep. Oh. Yep. Yep.
Bracket x minus 2
Excellent.
bracket squared plus 80.
Fantastic. Half a tick there. Can we now find A? Why? Right, this point here, it says yes, it's 60. What is that actual coordinate? 0, 60, aka your y-intercept. So wherever, that's your x value, that's your y value. You're going to go 60, A, 0 take 2 squared plus 80, and away you go. Okay? Now,